Hello, welcome. Let us understand about one more type of neural network called recurrent neural network or RNN. A recurrent neural network is a special kind of neural network that is designed to understand sequences. Sequences means things that happen over a time, like sentences, music, even stock prices. Main thing about RNN is it can understand the sequences. RNN has a memory. It remembers what has happened before so that it can make a better decision now. It works by passing information from one step of the sequence to the next step, allowing it to understand and predict the pattern in things like a text, speech, or time based data. In simple terms, RNN is an AI that reads or processes the things in order, like words in a sentence, and remembers what came before to make a sense of what may come next. In simple terms, RNN is an AI that reads or processes the things in order, like reading a sentence word by word. It remembers what came before to make a sense of what is coming next. Let us understand this with a real life analogy. Think of it like reading a book one word at a time. Each word depends on the word that came before it. To understand the sentence, you need to remember what was said earlier. That is what RNNs do. They keep track of previous information as they go forward. We have discussed about FNN and CNN earlier, and we have understood they do not have memory, but RNN has a memory. RNNs are useful when we need to maintain the order, or a order of data matters, or a context or a history affects the meaning. Let us understand how RNN works. You feed the data, that is the input, and it has a memory, that is the previous memory of what has happened earlier. And based on this previous memory and the input, it predicts the output. And then this output is again goes in the similar loop. It again follows the same cycle here. This output is passed on to the next loop as a memory of what happened earlier. Let us understand some of the limitations of RNN. RNN struggles with long-term memory, can forget the things that has happened many steps earlier, and it is hard to train. Training becomes unstable for a long sequence. It is slow, that is compared to transformers it is slower. You might have a question that whether a transformers can do the same task. Answer is yes. Transformers can do some of these complex tasks better than RNN. So many of the systems are migrated from RNN to the transformer architecture. For example, Google search earlier before 2018, they used RNNs to predict the next word. As soon as I type here, I love to eat AP, next words it has already predicted some possible words. Earlier, for this purpose, Google used RNN or a recurrent neural networks for this purpose. Now, today it uses a transformer based models like BERT, because these transformer based models provide a much more faster, accurate, and context aware. So RNNs are no longer main tool in a large scale systems like a Google search. Now let us understand some of the real life use cases of RNN. RNN can be used for text prediction. That is, for example, when you are typing on a keyboard, it predicts the next words based on what you have typed. RNN may also be used in music generation. It generates a music note by note. RNN can also be used in speech recognition. It converts the spoken words into text by listening over a time. And RNN can also be used in stock forecasting. It predicts the next stock value based on the previous trend. And RNN can also be used in language translation. Translates the sequence by understanding the whole sequence. So far, we have understood what is RNN, what are its limitations, and some of the real life use cases of RNN. Thank you for watching.